Hello everybody, welcome back to Geometry 7.3, Similar Triangles, AA Similarity. Our learning objectives: use the AA Similarity criterion to prove triangles similar and solve problems by using the properties of similar triangles. Before we start looking at the exercises, let's look at the Theorem 7.2 Properties of Similarity. Reflexive property of similarity. A triangle is always similar to itself. Symmetric property of similarity. If one triangle is similar to another triangle, then the other triangle is similar to the first triangle, of course. And the last one, transitive property of similarity. If one triangle is similar to a second triangle and the second triangle is similar to a third triangle, then the first triangle is similar to the third triangle. Alright? I think we've seen something like this before. The reflexive, symmetric, and transitive properties. They apply to more things than just similar triangles. Let's start looking at some exercises. Our first example, we have triangles KJL similar to triangle M and L. Find the value of X. From the similar properties of triangles, we know that sides are proportional. Okay, so if these two triangles are similar, then we can say that KL, which is X, over ML, we go by the letters. So KL is the first and last, then ML, similar to JL, which is this one, over JL is these two, ML. Let's substitute. KL is X, ML is 15, equals JL is 12, and LN is 10. So 10x equals 12 times 15, which is 180. That means x equals 18. Alright? Pause the video and redo this yourself. Our second example, a person 4 feet tall casts a 3 foot long shadow at the same time that a telephone pole casts a 9 foot long shadow. How tall is the telephone pole? We know that sun rays at a certain time, at any time of the day, they make proportional shadows. Okay, so which form proportional triangles or similar triangles. Let's say this is X, so the side corresponding to this is this. So X over 4 equals, this corresponds to this, 9 over 3. So 3x equals 4 times 9 is 36. X equals 12. So the height of the telephone pole is 12 feet. Okay, let's do some more exercise. So identify the similar triangles, then find each measure. Okay, let's look at this first example. We have this angle equals this angle, and this angle and this angle, they're both right angles. So we have two angles, two congruent angles, which means that triangles are similar. What triangles? X, Y, Z, and J, K, L. We want to find the value of X, so let's look at a pair of corresponding sides. X over 13, so these two are corresponding, equal this and this, 20 over 10. So 10x equals 260, x equals 26. Okay? And that makes sense, because if you multiply 10 by 2, you get 20. And to go from 13 to 26, you multiply by 2, which is the same ratio. Alright, let's look at this. Second example, we want to find the measure of BC, which is x. First, we need to make sure that these two triangles are similar. If we look at these two angles, vertical angles, okay, and because these two lines are parallel, this angle equals this angle. So we have two congruent angles. In fact, also these two angles. So the since we have two congruent angles, the triangles are similar. Okay, so triangle ABC similar to triangle DBE. Okay. Now we need to find the value of x. So x, which is BC over BE, alright, equals AC over ED. AC over DE or ED. Alright, so x over BE, how much is BE? 38.6 equals AC, which is 30 over DE, which is 60. Okay, this is 1 over 2. So 2x equals 38.6. That means x equals 19.43. Okay, and that's it for these two examples. Alright, identify the similar triangles, then find each measure. Okay, now in the first example here, this angle is common between the two triangles, the small one and the large one. Okay, and because we have two parallel sides, so these two angles are congruent and these angles are congruent. So definitely these two triangles are congruent. Excuse me, these two triangles are similar. Now the triangles are MPL similar to triangle MVK. Alright, so ML x over MK, alright, which is MK is x plus 9 equals MP over MV, which is MP is 16 and MV is 16 plus 8, 24. Okay, so multiply, cross multiplication, 24x equals 16x plus 16 times 9 is 144. 16 times 10 is 160 minus 16 is 144. So 8x equals 144. X equals 144 divided by 8. How much is 144 divided by 8? 18. Okay, and that's it for our first example. Okay, make sure you understand how we got this. This in the small triangle, this is x. In the large triangle, this is x plus 9. So be careful with that. Okay, same thing here. In the small triangle, this is 16. In the large triangle, this side is 16 plus 8, which is 24. Let's move on to the second example. Alright, now we need to identify the similar triangles. This angle is common, and these two are corresponding angles because of the parallel lines. So definitely FRQ is similar to FNP. Okay, so the small triangle FQ over FP, which is 30, FP equals FR in the small triangle over FM in the large triangle. Okay, now let's substitute. FQ is 32 over FP is x plus 32 equals FR 30 over FN 30 plus 10 30 over 40. Okay, which is 3 over 4. So 3 times x plus 32 equals 4 times 32. Okay, 3x plus 96. How much is 4 times 32? 128. So 3x equals 128 minus 96, which is 32. Okay, is that correct? Yes, so x equals 32 over 3. So that's our final answer. You can leave it like this as a fraction, alright, or you can simplify it 10 2 over 3 or 10.67, whatever. I would leave it just like this unless specified in the question. And that's it for today. We've used similar properties of similar triangles to solve some exercises, problems. I hope you stay safe, and we'll see you in the next video. Bye for now.